In the previous lesson, I said that JavaScript doesn't have classes, at least not in the traditional object-oriented programming sense. Nor did it have inheritance in the traditional object-oriented programming sense. I explained how JavaScript is focused on objects and the linkage between objects that are based on objects. We also looked at constructor functions that allow you to construct a new object from a function call, but this really isn't a class in the traditional object-oriented sense either. But technically, JavaScript does actually now have classes, or the notion of a class, and it was introduced in the last version of JavaScript. Now, JavaScript classes give you the impression that you're working with something that resembles traditional object-oriented programming, but in reality, nothing has really changed. JavaScript remains object-focused, and objects can still be prototype chained together. I don't know how to say it correctly. JavaScript classes are what is termed syntactic sugar on top of the existing JavaScript object and prototype models. That term, syntactic sugar, you'll see that frequently in software development circles. It's programmer slang. That means that they added a few keywords and structures in JavaScript, but these merely map to existing features of JavaScript. They don't really add new features per se. So the syntactic sugar might help those who are transitioning from more traditional programming languages to JavaScript, but JavaScript purists are quick to point out that this new feature, the class feature in JavaScript, may do more harm than good, because at the end of the day, you still have to make the switch from classic or traditional object-oriented programming to a more object-based prototype inheritance, if you want to use that term. And if you're working with prototypes, you have to learn the things that we talked about in the previous lesson. Okay, so in a nutshell, let's talk about what a class is and define a class. It's essentially a way to define and create objects. And so just like there are function declarations and function expressions, now there are class declarations and class expressions. So let's start off with just looking at a class declaration. And so you do something like class car, whereas an expression would be more like let car equal class and then whatever. Okay, so fairly simple and hopefully straightforward. It's basically declaration, you give it a name, and expression is, well, it's an expression. So JavaScript classes can have a constructor function that gets called automatically whenever you use the new keyword. So let's go with the declaration version of this. I'll comment this out, this expression. All right, so inside of the declaration, let's create a constructor function. You have to use the term constructor. Then you can add any input parameters that are essentially going to map to properties that you're going to add to a new instance of an object based on this class. So here again, you do something like make, model, and year. And just like in the constructor functions that we learned about a couple of videos ago, you would still use the this keyword, make equal make, this dot model equals model, this dot year equals year. Okay, so you can see similarities here, right? And then to create a new instance of an object based on this class, you would do let my car equals new car, passing in, you know, BMW 745 Li and the year 2010. Okay. So again, I want to make the point here that that word or that name of your constructor function in a class definition in JavaScript has to be named constructor in order for this to work. And here you're still using the new keyword. New still creates an object instance. It still passes it to the constructor function. Now, in this case, the name of the function is not car. The name is constructor, but you're passing input parameters into that constructor method and then using this, in this context, it's the new empty object that we're attaching properties to and then initializing their value to the arguments that are passed into the constructor. All right, hopefully that all makes sense. And it's similar enough to what we've already learned that it kind of, you can see where things are mapped. Again, syntactic sugar on top of what already exists. All right, so you can also create methods on the class. In fact, let me do it outside of the constructor method. So here I want to create a print method. And, you know, I can do something like console.log, and then I'm going to go ahead and use our special string syntax, interpolation syntax. Let's make some space for myself here, and I'll say this.make, this.model, and I'll format it a little bit with some parentheses, but inside we'll go this dot here. All right, so here again, now that I have an instance of my car class called my car, I can call print, like so. And so let's go node classes, and you can see I get the nicely formatted version of the information in my car class calling the print method. All right. Now, beyond these basics, you can actually approximate inheritance, at least inheritance in the classic object-oriented programming sense. So in our case, let's kind of go down here to the very bottom, and I want to create class sports car, and I have to use the keyword extends car. All right, so right off the bat, when I do that and I create a new instance of sports car, let's do that. So let my sports car equals new sports car. Now I don't have a constructor function defined, but when I use the open parenthesis, notice that IntelliSense still sees that I have make, model, and year. Why is that? Because by extending sports car from car, I still get the constructor method defined on car, and I can still set the make, model, and the year. So here, let's go Dodge Viper. And I don't even know if there's a 2011 version of it, but I don't know if they stopped making it or if they're still making it. I'm not even really sure, but it doesn't matter. All right. So at this point, and we can even call my sports car dot print. All right. And now we get that printout here like so. So we're extending, we're borrowing the entire definition of our class, and we are getting the constructor method defined in car. We're getting the print method defined in car, but I can extend and push beyond the boundaries of the car's definition by adding properties and methods. So for example, here, let's just add a quick method. And I'm going to call it, since it's a sports car, we're going to create a method called revEngine, which will be a unique printout of information. So console.log, and we'll do something .vroom goes the this.model. Okay. So now I can call my sports car dot revEngine, and I get vroom goes the Viper. I guess I should have added a space right there. All right, now what if I were to do this? I still have my car. Can I go my car revEngine? Let's see. Nope, can't. Why? Because it says revEngine is not a function. Well, it is a function. It's just not defined on the car class. It's defined on the car class's inherited child called sports car. All right, so you can't access revEngine from the car class. And you know what? Honestly, there's more to it than that. There are some advanced scenarios, but that should be enough to show you what the class keyword and the extends keyword can do and how it operates. And you can see the rough equivalence between what we did here and what we've done previously. And hopefully you can kind of see that there is a mapping, and that ultimately what's going on behind the scenes, though, is that we're creating a sports car object, and its prototype is car, and we're adding on a rev engine method. But when we look up the constructor function, when we look up the print method, it's still using prototypes behind the prototype chain behind the scene to manage all that. It's just JavaScript is kind of covering that up just a little bit with some different syntax. Okay? So my personal opinion is that if you're coming from a traditional object-oriented programming environment and you need to become productive very quickly because you have a looming deadline or whatever the case might be, you might be better off trying something like TypeScript, which was created by Microsoft. It gives you the feel of C# and Java, more so than JavaScript will, and it gives you more of that traditional object-oriented programming look and feel, and ultimately it will transpile down to pure JavaScript. Kind of out of the context of this conversation, just what you should do is go to typescriptlang.org, and you can study up on it a little bit, but it's essentially a super type of JavaScript, meaning anything you do in JavaScript will work in TypeScript, but TypeScript gives you some extra features that will make it feel more like Java or C# if that's something you need. But most importantly, if some of this doesn't make sense, the things that we've talked about here, don't beat yourself up about it. Again, this is a feature that was added for a specific demographic, people coming from other programming languages. It may not have been intended for somebody who is just starting to learn JavaScript. So don't feel like the pressure now to go out and learn traditional object-oriented programming before you can understand how to use class. You don't even need to understand this. It's just, again, something for a stopgap measure for people coming from another programming language. So it might not be immediately obvious to you in what situation you might find yourself using this and why you would prefer this over what we looked at in the previous lessons. But at this point, just focus on the language, the fact that these things exist, the fact that they were added for a reason, and the reason is to help somebody else, maybe not you specifically, somebody coming from a different background, to make that transition to JavaScript. And you know, ultimately, I think with a lot of the things that we're talking about here, their usefulness will reveal themselves to you later whenever you start programming and creating real applications with this language. All right. So you're doing great. Just hang in there. We're making great progress. You know, the fact of the matter is that learning is iterative. And if this is your first attempt at learning any programming language or your first attempt at learning JavaScript specifically, no doubt you're going to need to come back to some of the ideas that we talk about, you know, in the coming days, weeks, or months. And you'll continue to come back to some of these ideas over and over. I mean, I keep studying and kind of pushing in new directions, coming back to studying the basics and then pushing a different direction. And you have to do that in order for these ideas to fully sink in over time. I mean, I've been working with JavaScript almost my entire career, and I'm still learning things. So it's just the nature of learning this sort of stuff. There's so many details, and there's only so much time in the day. So don't beat yourself up. You're doing great, and you're taking great strides towards understanding JavaScript. So hang in there. We're just kind of entering the home stretch now. You've come so far, just a little bit more, and then you can honestly say that you've got a firm foundation of JavaScript to build on. Okay, a little encouragement to get you over the hump here. All right, we'll see you in the next video. Thanks.